Hi, and welcome to an introduction to artificial intelligence. A quick disclaimer up front, this audio has been generated by an artificial intelligence model based on recordings of my voice. So this isn't me speaking, but an AI that sounds pretty similar to me reading a script that I've written specifically for this video. So we're going to cover the following things. We're going to have a look at what is artificial intelligence and go into a little bit of the history and the context around it. We're then going to dive into what is generative AI, where we're going to cover why this has become such a hot topic recently, and have a look at ChatGPT, which is the platform by OpenAI that has really driven a lot of the hype since it was released in November last year. We'll then look at why we think the hype is real, and this technology isn't just a new shiny thing. It's a very disruptive technology that is going to be here to stay, and we're only really at the very beginning of understanding what its impact might be. Let's get into it. So what is artificial intelligence? Well, it's a term that has been around since the mid-1950s, when it was defined as a field of computer science that's focused on creating technology that can perform tasks associated with human intelligence, such as learning, reasoning, and decision making. This definition was coined by a team of researchers that built on previous work that was done by Turing, Tesla, Bayes, and others. And just to go through a very brief history of the development of artificial intelligence, it's been a field of scientific research now for 75 years. And as I said, it started back in 1947 when Alan Turing gave a lecture on computer intelligence, but the term artificial intelligence wasn't coined until 1956. There was quite a lot of work done on artificial intelligence through the 1950s and 60s, but we then entered a kind of AI winter. That was until 2011 when IBM Watson was released and appeared on the American TV show Jeopardy against the current champions, winning first place, a prize of $1 million, and really grabbed some headlines. Since then, there's been a rapid amount of development over the last 12 years or so. Google released a really important technology called the Transformer architecture in 2017 that had been absolutely revolutionary. You'll see why this has been so pivotal a little bit later in this video. We then had the release of GPT-3, the first generation of GPT models released by OpenAI back in June 2018. It had 117 million parameters, which compared to today's models is incredibly small, but it already showed a lot of promise. Google released a similar model called BERT of a similar size in October 2018. Then OpenAI released GPT-2 in 2019, which was an order of magnitude bigger than GPT-1 with 1.5 billion parameters. I'll give you a good explanation of what parameters are later in the video. GPT-3 was released in May 2020, and that had another big leap in size with 175 billion parameters. And then ChatGPT was released in November 2022, which was based on a version of the GPT-3 model that had been fine-tuned for chat with humans. So that's a very brief history of artificial intelligence. And next we're going to cover the main branches of artificial intelligence in order to put this all into context. So there are 6 main branches. We have machine learning, expert systems, natural language processing, computer vision, speech recognition, and robotics. These 6 different branches are really split into 2 main areas. The ones that deal with structured data and the ones that deal with unstructured data. What we mean by structured data is data that has columns and rows and is in a format that is very easily understood by computers, such as tables and databases. It's with unstructured data that there has really been a lot of the progress over the last 10 years or so. And what we mean by unstructured data is things like long passages of text, videos, or images that don't have an inherent structure to them. So computers find it hard to understand. So the domains of artificial intelligence that deal with unstructured data have now got to the place where it can deal with that unstructured data in a very, very sophisticated way. And it's this progress that has led to the development of generative artificial intelligence technologies. So what is generative AI? I think it says a lot that this official definition from the World Economic Forum was only released in February 2023, so only a few months ago. And it states that generative AI refers to a category of artificial intelligence algorithms that generate new outputs based on the data they have been trained on. And unlike traditional AI systems that are designed to recognize patterns and make predictions, generative AI creates new content in the form of images, text, audio, and more. So generative AI is, for the first time, a computer system that is able to generate content on its own based on that data that it's been trained on. Having said that, though, I think it's important that we put the term artificial intelligence into context for what it actually is, because if you go back to that definition from the 1950s that we talked about a little bit earlier, it's a very, very broad definition. It was Ted Chiang in an interview with the Financial Times a few months ago that I think hit the nail on the head. For those of you who don't know him, Ted Chiang, the author who wrote the short story that the movie Arrival was based on. And he said, when asked if he had to invent a different term for artificial intelligence, what would it be? And his answer was instant, that artificial intelligence was just applied statistics. And I think that's worth bearing in mind as we go through not just this video, but whenever you're thinking about generative artificial intelligence, these models, these platforms, they're not conscious, they don't have intelligence per se, they're just really, really good at maths, and you'll see how that plays out in when we look at how these models work shortly. So generative AI leverages two of those main branches of artificial intelligence that we saw earlier. It uses neural networks and natural language processing. Neural networks is an artificial intelligence technology that is designed to work like the human brain. It's made up of millions and millions of artificial neurons that are all connected to each other, very similarly to how biological neurons are connected in the human brain. And natural language processing is a technology that helps computers understand human language. It enables people to interact with computers and digital devices in a more natural and intuitive way. You will have seen a lot of natural language processing at work in technology over the last 5 years or so with devices like Alexa and Siri and other voice assistants. But before we dive into how generative AI works further, it's probably worth us just covering a few of the different pieces of terminology that is used quite a lot in this space, because it can be confusing when talking about some of this if you don't know what some of this language actually means. First, I want to talk about tokens. So tokens can be thought of as pieces of words. And for some bizarre reason, a token is about 4 characters in English, which is on average about 3/4 of a word. I'm not quite sure why they didn't round it out to a whole word, but there it is. GPT-4, the latest model from OpenAI, can ingest a prompt of up to 32,000 tokens, which is approximately the length of the book Animal Farm by George Orwell. So a huge amount of content can be ingested in a prompt when you are asking questions of the GPT-4 generative AI model. The next term I want to cover is parameters. So parameters are talked about a lot in this space, and they're like a generative AI model's knowledge or memory that is built from all the data that it's been trained on. I mentioned earlier that GPT-3 has 175 billion parameters, which is kind of like someone having read a whole library of books and being able to remember absolutely everything in all of those books. And I don't mean just every single word. I mean every single word, every sentence, every paragraph, and every chapter, all in context of each other. So it's a huge amount of memory that these generative AI models have. And then the last term I want to cover is something called dimensions. Dimensions are like the different aspects, features or meanings of a word. So in this example, if you took the word intelligence, it has similarities to concepts such as problem solving and understanding and knowledge and learning. And dimensions are what allow a generative AI model to understand how close or similar a word or phrase is to other concepts. These dimensions are a mathematical representation called a vector, which is a set of number. GPT-3 uses 12,288 dimensions or numbers in a vector, and it's these numbers that are adjusted by the model during training to help it accurately predict the next word in a sentence. And we'll come back to this shortly. So at a very basic level, this is how generative AI works. In this text-based example, the model takes a text input, which it turns into a vector of 12,288 dimensions, which is then fed into the large language model. The large language model will then output an image or text or video or any other type of content that it has been built to output. And the way that it does that is an iterative process. Now, the way that a generative AI model outputs text and the way that it outputs images is slightly different. but the principles are the same. And how a generative AI model creates content is actually very basic. It is just predicting what it thinks the next best word should be in a sentence based on the context of the prompt that you've given it. So in this example here, if you gave a generative AI model the word there, it would then predict that the next likely word is are. Then the next likely phrase after that is lots of. And then after that, it predicts the word reasons. So it comes up with the sentence, there are lots of reasons. This is a very, very basic example, and we'll get on to why some of the behaviors of these large language models have become so sophisticated over the last year or so shortly. Having said that, though, this technology has actually been around for quite some time now, and we've been carrying it around in our pockets for years. So anyone who has a modern mobile phone, whether it's running iOS or Android, will have seen text prediction on their device. The text prediction on a mobile keyboard is actually running a small generative AI model that is able to predict what the next word is that you're typing in a sentence. These small models just haven't had the sophistication and broad capabilities of the larger generative AI models that we're now seeing. This leads us to the question of why now? Why has generative AI become such a hot topic? And why has this technology taken the world by storm over the last 9 months or so? And there's a few reasons for that. The first is something called scaling laws, which is something that OpenAI came up with a few years back. And their hypothesis was that as you scaled the size of generative AI models, so as you scaled the number of parameters that the models have, you would also see an increase in the capabilities that the models had. So the race has really been on to be able to create bigger and bigger models that then start to display more and more capabilities. And that means that you have to have a huge amount of data available to be able to train generative AI models of larger and larger sizes. It's only really been recently that that amount of data has been available. So here you can see a table of the data sets that GPT-3 was trained on. It was trained on something called Common Crawl, which is effectively a lot of text that has been collected from the internet. There's then a data set called Web Text 2. They use a load of books and Wikipedia as well. And that whole data set was a total of about 500 billion tokens that the model was trained on. This training resulted in a model of 175 billion parameters. The next thing that has really held this field back up until recently has been the amount of compute power available to be able to train a model on increasing amounts of data. The computer hardware that these models are trained on are called graphical processor units, or GPUs. They're not the main computer chips that run your laptop or your desktop computers, and their availability has been relatively constrained. This is because you need the most cutting edge new versions of these chips to train a generative AI model, and it's become a lot more expensive to build these newer chips over the last few years as the technology has been shrunk. So the whole generative AI industry has been and continues to be relatively hardware constrained in training their models. And then the last thing, as I mentioned earlier, is the transformer model architecture that Google came up with back in 2017. This really was a big step change in how you build and train generative AI models. Without transformer models, we wouldn't have seen the large models that we see today. So it took Google releasing transformer model architecture back in 2017 to really unleash the ability to scale generative AI models to the size that we now see. So what happened in 2021 when GPT-3 was released is that we passed a really important threshold. And that was a threshold of 100 billion parameters in the size of a generative AI model. This was the first time that a model of that size had been released. It's the first time that training a model of that size had even been taken on as a challenge. And I think that it's a really interesting threshold because when you pass 100 billion parameters, you start to see a lot of emergent behavior. This is a fantastic graphic from Google that shows all the different capabilities that present themselves as you increase the number of parameters that you get in a large language model. And you can see how much more competent they get, but also the breadth of things that they were able to do as the number of parameters scale. Now, emergence is a super interesting area, and it's something that we see in nature as well. It's a natural phenomenon. For example, when you see a murmuration in a flock of birds, that is a form of emergence. It's essentially complexity coming out of a lot of small, simple decisions. And that's the kind of thing that we're seeing in these large language models. And the reason why they've become seemingly so useful so quickly, it's because we've passed a large threshold and a lot of capabilities have suddenly emerged from having generative AI models of that scale. But there is a challenge with that scale as well. As you increase the size of generative AI models, you also see something called hallucinations. You might have heard of hallucinations in relation to generative AI in some of the press. It's an area that is getting a lot of scrutiny right now. Hallucinations are essentially when a generative AI model gives an answer that isn't based on the data that it has being trained on. Its answer can't be linked back to any data that it has seen, and the model is making connections that aren't really there. The challenge with these hallucinations is that generative AI models present themselves very confidently, so it can be very, very hard to spot a hallucination. This is why all of the terms and conditions for generative AI platforms and all of the guidance when using these models is to be aware that sometimes you can get answers that aren't necessarily factually correct, and that you should always fact check anything that you get out of the models. I think hallucinations are a really interesting area. The industry right now is looking at ways to stop them from happening. This is one approach. But I like to think of hallucinations as the imagination of generative AI models. And I think that we should look to understand them better and potentially harness them more for creativity. However, we absolutely need to be able to flag to users when something has been produced because of a hallucination in a model, so that we're being really transparent about what is factually correct and what might just be a flight of fancy coming from the model. So what is ChatGPT? ChatGPT was built by a company called OpenAI, which is only 7 years old, and they have less than 400 employees, which is tiny in comparison to the large digital platforms that they kind of coexist with now. OpenAI was started back in 2015, and their mission was to ensure that artificial general intelligence, by which they meant highly autonomous systems that outperform humans at most valuable work, benefits all of humanity. The company was founded by Elon Musk, Sam Altman, who is their current chairman and CEO, Greg Brockman, Andrej Karpathy, and Peter Thiel, amongst others from Silicon Valley. And it started as a non-profit organization, but had to transition to a for-profit organization back in 2019. And the reason for that was the cost of the hardware that they needed to procure to train all of their generative AI models. They just couldn't do that by relying on donations from their founders and other people. So they had to transition to a for-profit organization. And when they did that in 2019, Microsoft invested $1 billion. Microsoft then invested an additional $10 billion earlier this year, valuing OpenAI at about $30 billion. And Microsoft currently owns about 49% of OpenAI. So they are by far the majority owner of OpenAI, and that is why they have been working so closely with them and get a lot of early access to the technology that OpenAI is building. So what have OpenAI been doing? Well, they have been building the generative pre-trained transformer model, or GPT model, and it released the first research paper on this in 2018. The paper demonstrated how a GPT model was able to acquire general knowledge through pre-training on a diverse set of text. This first model, as I said earlier, had 117 million parameters, and it could take a query or prompt of just over 1,000 tokens. They then released their second model about a year later, which had 1.5 billion parameters, and they doubled the number of tokens that it was able to take in a query. That was then followed about a year later again by GPT-3, which increased the size of the model to 175 billion tokens and kept the same kind of query size and prompt size as the GPT-2 model. The data that GPT-3 was trained on was originally up to October 2019. Then they released the GPT 3.5 model, which was the model that ChatGPT was originally based on. It was similar in size to GPT-3, but OpenAI doubled the amount of tokens that it could take in a query, and they updated the training data to September 2021. They also did something called fine-tuning, which is adjusting the model so that it was well disposed towards chat with humans. That's why they named it 3.5, because it really was just a fine-tuning and a refinement of the GPT-3 model. And then we saw GPT-4 released, again about a year after GPT 3.5. Now, OpenAI haven't officially released a lot of information or any research papers about GPT-4, but there have been a few leaks and a few things that have been stated in the press that we can start to piece together to help us understand how it is different from GPT-3 and GPT 3.5. So it's thought that GPT-4 is another order of magnitude bigger than GPT-3, so 1.76 trillion parameters. And they've also massively increased the query size to about 32,000 tokens. But the data that it's trained on is still only up until September 2021. Again, the GPT-4 model has been fine-tuned for chat, but it's got a lot of other things going on under the hood as well. GPT-4 is what is called multimodal. These features haven't been widely released yet, but what multimodal means is that it is able to take in and to output different types of content. So it can take in text in a prompt, but it can also take in an image. It can output text as well as images, code, tables, data, visualizations, and lots of other forms of content as well. OpenAI also added the ability for GPT-4 to browse the web. That feature has actually been deactivated recently because there have been a few lawsuits around it, but I expect it to be a feature that will come back in the near future. GPT-4 also has something called plugins, which are effectively little tools that people can build that the model has access to do loads of different things. And some of these tools have a wide variety of use cases. So you can ask it to look up flight times, you can ask it to book you a table at a local restaurant, you can ask it to read a PDF for you, you can ask it to do complicated maths problems and things like that. The plugin ecosystem is a really interesting one because you're able to supplement the model with lots of other capabilities. And I think that's quite an exciting area for the future. And then the last thing that GPT-4 has brought to the table is what they call a mixture of experts. GPT-4 actually isn't just one model. It's probably about 8 different models that all talk to each other under the hood. So you've got 8 models that have all been fine-tuned and trained slightly differently for different domains and different priorities, such as safety versus fact-checking, for example. And those 8 modals are all kind of pulled up together into one when it's creating the content that you would see when interacting with GPT-4, which is a very interesting approach. I think this is probably the future of where these large generative AI models go, that under the hood, there are actually a number of different models all working together to get to the best possible answer. So what do these developments of OpenAI's GPT model mean in terms of performance? This is a great little chart that just shows the average human performance and the top human performance against different things like SATs and maths competitions and civil service exams and lawyer qualification tests. And it looks at the performance of GPT-4 as well as ChatGPT and TeXtDaVinci 3, which is GPT-3. You can see here that the yellow performance of GPT-4 is much more competent than the previous GPT models. It is now on a par with top human performance on SATs and exceeds the average human performance on LSAT. And there's loads and loads of different exams and tests that have been done with these models. And it's fair to say that GPT-4 in general has got a very, very high capability when it comes to matching or exceeding average human performance across a whole range of domains. So ChatGPT, as I said earlier, was originally based on the 3.5 model and was released on the 30th of November 2022. It was the fastest growing technology that humanity had ever created, taking only 2 months to hit 100 million users. That was blown out of the water a little while ago when Meta released Threads, which reached 100 million users in a weekend. But I'm not counting that, as they already had an install base of billions of users across Instagram and Facebook to take advantage of. We're now nearly only a year in, and we've already seen the release of GPT-4. And we have also seen web browsing introduced. We've seen plugins. We've also seen something called Code Interpreter released in beta. Code Interpreter is a fascinating addition to GPT-4 that is really like having a data analyst in your pocket, and it can do so many different things. It was only released in beta a couple of months ago, so it's still being tested, but from what I've seen, it's going to be a huge game changer. For example, you're able to pull in data and ask it to analyze the data and pull insights out for you, and it does it in seconds, which is amazing. It can also visualize those insights. It can produce lots of graphical graphs and diagrams and tables of data as well. So a very, very exciting area. Building on all this, ChatGPT is actually now at about 200 million unique users per month. So it got to 100 million users in 2 months, and now it has doubled that again to 200 million users. And what I find quite interesting with this is actually the visit duration as well. So on average, everyone who visits ChatGPT is there for just over 8 minutes. And that is starting to get close to the amount of time that people spend on Twitter and Facebook. And the scale, I think, will continue to grow. It's also interesting to see that there's this other generative AI platform called Character AI, and its visit duration is 28 minutes, which is phenomenal. I'm not going to go into Character AI in too much depth in this video, but I think it's worth checking out if you have a minute or two. It's very, very popular amongst younger users and allows people to create their own characters to then have a conversation with. And there's hundreds and thousands of characters that have now been created on this platform, and it's quite a lot of fun. So definitely worth checking out if you're interested in understanding how some of the younger users are interacting with generative AI now and seeing it really as a form of entertainment as much as anything else. So where is ChatGPT going next? Well, this is a quote from Sam Altman, the CEO, when he was on his tour of the world earlier this year, championing regulation. And he said in an interview in Paris that what we will see is better, smarter, cheaper, faster, and more capable models. So just breaking that down, what does that mean when he talks about better, smarter, and more capable? What he's really talking about is the continued fine-tuning of these models and the release of Code Interpreter that I talked about a little bit earlier. They're going to release more multimodal features so it can describe images. ChatGPT could also output images and other content as well in the future. And we'll also see the evolution of those plugins that I talked about earlier. And that's a really, really exciting space when it comes to being cheaper. Currently, GPT-4 costs about 3 cents per token for a query, and that can go up to 12 cents depending on which versions of the model you're using and how much data you're feeding in. But compared to their 3.5 model, that's very, very expensive. So they're working quite hard on how they can make it a lot cheaper to use GPT-4. And really drive down the cost, because when you start using these models in volume, the costs can increase quite significantly, and that will be a barrier to adoption in the medium term. And then faster as well. At the moment, GPT 3.5 runs about 4 times faster than GPT 4. That really comes back to the hardware constraints that I talked about earlier. That is really holding OpenAI back at the moment, but they will be actively working on how they can make GPT 4 a lot faster. There are other small, interesting hints that came out of Sam Altman's global tour. So OpenAI are still not training GPT-5, although interestingly, they did recently trademark GPT-5, which might hint at them starting the training sooner or later. OpenAI are still heavily constrained by the number of GPUs that they have available to train their models on, as is the majority of the industry. They also want to increase the context window of GPT-4. So at the moment, it's a maximum of 32,000 tokens, but they think that 1 million tokens are plausible. And actually, there's another model called Claude 2 from a rival company called Anthropic that is able to take 1 million tokens at a time, which is a huge amount. And then the most interesting thing, I think, is the fact that they're looking at what a stateful API looks like. And what that really means is an API that remembers the conversation history that you've had with it. Adding memory to these models and knowledge about all the different things that you have asked it in the past, I think is a really interesting area of development going forward, because arguably one of the things that holds these models back right now is they don't have that persistent memory of the conversations you've had and the things that you've asked and the content that it's produced for you. So that, I think, will be a big step change when that kind of capability is released. As I said, Sam Altman has been championing for regulation, but has also said that the open source community is really, really important to the development of these models going forward. He also said that these scaling laws that we talked about at the beginning still hold, so making larger and larger models will continue to yield performance. So that's ChatGPT and what's coming next. Now, I just want to turn our attention to why I think the hype around generative AI technology is real. It's undeniable that ChatGPT took the world by storm. That can't be underestimated. And there are 3 main reasons why it did that. The first was the scale point. It was the first model to pass that 100 billion parameters benchmark, and therefore had all of these emergent behaviors that we hadn't seen before in a generative AI platform. The second reason is it had a really intuitive interface. I mean, it doesn't get simpler than the interface you have on ChatGPT, which meant that anyone could go to the platform and start asking questions immediately. It really didn't need any kind of prior knowledge of how anything like this works, and it made it really simple for people to interact with. And the last reason was the fine-tuning of this model and the fact that OpenAI put so much time and effort into fine-tuning it for chat. This made the responses that it came back with when you asked it a question really, really good. So you might have heard of some of these other generative AI platforms. I just mentioned Claude 2 from Anthropic. There's something called Llama from Meta. Stable Diffusion is an image generator, so is Midjourney. Bard AI is Google's version of a generative AI platform. DAL-E is another image generator that comes from OpenAI. There's a model called Jasper, and there's a model called AlphaCode by DeepMind as well. And for me, DeepMind is one to keep an eye on. For those of you that don't know, DeepMind was a very, very progressive artificial intelligence business in the UK. It was bought by Google about 10 years ago. And they're the people that are behind the artificial intelligence model that beat the world's best Go players in China a few years back. They're probably going to be releasing their version of a generative AI model to the public in Q4 this year. It's called Gemini, and the big difference that you'll see in that model versus the other ones is that it's going to have the ability for more longer term planning and strategic thinking. There are rumours that they want it to be a personal coach for people as well. One of the drawbacks of the current generative AI models is they're very lazy. They're essentially trying to complete a sentence in the quickest and simplest and most efficient way possible. Whereas the approach that DeepMind is taking is to really break down and slow down how these models approach a problem that it has been given, and to think about multiple ways of solving it before then evaluating the best way, before then presenting that back to the user. So I think the capabilities that DeepMind are looking at are going to be really interesting, because I think it's going to take generative AI models to the next level. But the interesting thing about this whole technology space, I think, was summed up really, really well by Carl Frey, who is the director of the Future of Work at the University of Oxford. And he was talking on a Guardian Live webinar a couple of months ago, and he likened the impact generative AI will have on knowledge work to the impact that the GPS system had on taxi drivers. So prior to GPS technology being around to be a taxi driver in London or any other big city, you had to know the city inside and out and the streets really, really well. But when GPS came along, it enabled anyone to have that same knowledge at their fingertips just by having their mobile phone running a maps application in the car. And that really gave rise to Uber and the ability for thousands of people to become taxi drivers almost overnight. And Carl Frey says that generative AI is really going to reduce the barrier to entry for knowledge work, because these generative AI models are like having a really powerful assistant in your pocket that you can use to help supplement the knowledge and the expertise and the experience that you've already got. His premise is that by having that technology, you can actually do much more with the time that you have, and across many more domains where you might need to have specific or technical knowledge. Now you can rely on these generative AI models having that knowledge for you. So you don't necessarily have the same barrier to entry as you have done previously for a lot of knowledge work, which I think is really interesting. Another reason why a lot of hype has been driven in this space comes back to something called the Llama leak that happened on the 3rd of March 2023. So I mentioned earlier that Meta had this generative AI model called Llama. They released that at the beginning of March, and the source code and all of the weights in the model were leaked to the open source community very soon after its release. Prior to that happening, building a large language model or a generative AI platform was really the domain of very large and resource-rich companies. The amount of investment in data and hardware and people and resources to build these models was absolutely huge. And it was only ever going to be the preserve of these large, rich companies up until March this year. But when the Llama model leaked, you went from having to spend $5 million and paying for 30 years worth of GPU compute to be able to train a model, to having this generative AI technology literally available at your fingertips. People could download it onto their computer or onto some cloud servers, and they could train it themselves at very, very low cost. This has led to an immediate leveling of the playing field, with many open source developers now able to run that Llama model locally on their machines. And that's greatly accelerated and diversified the development of generative AI platforms, which I think can only be a good thing. And you don't need to take my word for how impactful this has been. Here is a quote from a series of tweets from an anonymous Googler engineer who was warning his senior management that they could lose out to open source technology in the race. And it's worth me just reading this out because it touches on a couple of interesting points. So they said that they've done a lot of looking over their shoulders at OpenAI. What will cross the next milestone? What will the next move be? But the uncomfortable truth is that we aren't positioned to win this arms race, and neither is OpenAI. While they've been squabbling, a third faction has been quietly eating their lunch. And they're talking about the open source community. They're lapping them. Things that they consider were big open problems are solved and in people's hands. And while the models still hold a slight edge in terms of quality, the gap with the open source community is closing astonishingly quickly. Open source models are moving faster, they're more customizable, they're more private and are more capable pound for pound, and they're doing things with $100 and 13 billion parameters that they are struggling to do with $10 million and 540 billion parameters. And they're doing it in weeks and not months. And this is absolutely played out over the last couple of months since then. And actually, Meta released the second version of Llama just a few weeks ago, and they did that directly to the open source community. They've done it in partnership with Microsoft, and I think that is going to be very, very interesting. I think where the open source community is absolutely excelling is getting more and more capabilities out of smaller models, and where that becomes fascinating. And it's one of the reasons why Meta opened up the second version of Llama a couple of weeks ago, is that we're going to see, I think, within the next year or two, models that are small enough and that have a similar capability to GPT-3, GPT-4, and are able to fit on a mobile phone. And when you have this kind of technology on a mobile phone, I think that is game changing, especially in countries and markets where internet connectivity, mobile internet connectivity isn't great, because all of a sudden you have a huge knowledge base on your phone without having to rely on an internet connection. And the ability of those models to do things with the other software on that mobile phone, I think it's going to be really interesting. So because of this, there's been a huge explosion of use cases for generative AI this year. We've seen it used for research, data analysis, text-to-speech, transcription, summarization of large volumes of text. We've seen image applications, text applications, music generation, video generation, the ability to learn languages. We've seen lots of bots being built, applications to coding, applications to data, some really interesting things going on in the gaming space, and a lot of drug development is now being done with generative AI models as well, which is finding new molecules and new drugs for treatments, which is absolutely fascinating. And we're already starting to see the real world impacts of this technology as well. In the top left, there's a platform that transforms an ultrasound image into an actual image of what your baby is going to look like, which is amazing. There's AI designed drugs. Doctors are using ChatGPT to improve how they talk to patients. Researchers are using this technology to decode what's going on in the brain, and are starting to see in comatose people the brain activity and the reactions that they have when they're given podcasts to listen to, which is fascinating. The Beatles are using it to create their final song with the voice of John Lennon, and brain implants with this technology are allowing paralyzed people to be able to walk with their thoughts as well. So I think we're getting to the point where this technology is going to be a key player in linking the brain to other forms of robotics, which is quite a scary concept as well, but definitely something that's in our medium-term future, and the investment in this space is exploding. So wrapping up, I think it's worth reminding you that generative AI is just very, very good applied statistics now. It's got a wide variety of use cases, and that is going to lower the barrier of entry for many kinds of knowledge-based jobs and tasks. OpenAI and ChatGPT have been a big disruptor, and I think they're poised to become the next large digital platform. They're not there yet. But I think that by the beginning of next year, you'll see the volumes on the platform, the amount of time that people spend on the platform, the frequency that they visit the platform really accelerate and start to challenge some of the other players like Twitter and Facebook. However, it's not just large companies that are going to influence the development of this space. The open source community is already having a huge impact. which is driving the development of a huge variety of applications and making it very hard to keep up to date on, I have to say, but very, very exciting at the same time. And lastly, these real world applications are, coming quickly, and there's a lot of experimentation happening across all industries. So that's a wrap. Thank you for watching this video. I really hope it's helped to give you a solid introduction to artificial intelligence and specifically generative AI. If you've enjoyed watching it and think other people would like it, please do share.